So on Monday we did conceptual development of operations, okay? And then I also told you that computation is pengiraan, okay? So computation, there are many methods of doing computation. We have the written algorithm methods, calculator computation, mental computation, abacus computation, and estimation, okay? So all you need to know all these methods lah, okay? So today we're looking at written algorithms, standard and alternative algorithms, okay? Okay, standard algorithm, standard addition, so we're going to look at algorithms today, okay? Written algorithms, standard and alternative. Standard algorithms, also known as standard written methods. This is the first algorithm that we always teach in school, okay? Sometimes this is the only one that we teach, okay? Standard written algorithms, okay? So let's look at the standard written algorithm for addition, okay? You already know this already, okay? 43 plus 39. So 9, 10, 11, 12, 2 and carry 1, 7, 8, okay? This is our standard written method, says 39 plus 49. Say you have three numbers, so 18, 19, 20, 21, 1, 2, 7, 11, 12, 13, okay? So we align the numbers according to the place value, okay? So this is the standard written method for addition, okay? So we have to teach this, okay? And then we have the standard written method for subtraction, also similar like this also. 43 minus 39, standard written method for subtraction. Standard written method for multiplication. Okay, this is standard written method for multiplication. For division, standard written method for division. This is how we do long division, is our standard written method, okay? So if we want to divide this number by 3, so 3 times 4 is 12 minus, so we minus 14 minus 12 is 2, bring down the 3 here, so 23. So how many times can 3 go into 23? 7. So 7 times 3, 21. We have a remainder of 2, or we can write here remainder 2. Okay, so this is our standard written method for division. Okay. Okay, so these are all the standard written methods for addition, subtraction, multiplication, and division. So we already know all this because you also studied this way in school, okay? So now we're going to look at alternative written methods. Alternative written methods are methods, other types of methods that we want to teach for students to use. Why do we teach alternative methods? Because not all children can excel in standard written methods. Some cannot understand and they don't like to use them. So different children have different preferences, okay? So that is why nowadays, even in UPSR, when we had UPSR, they can use any method already. No more just focusing on standard written method, okay? Nowadays, children are encouraged to use any method that they like. Okay, so let's look at the alternative algorithms. For addition, we do for addition first. Okay, so this is the first alternative algorithm, that is addition based on place value. That means when we say, for example, okay, example, we want to do 43 plus 39 equals to how much, okay? So we use a place value chart for this, okay? So when we want to teach them addition according to place value, we try to use a place value chart in the beginning, okay? So we have 43 here, so 4 tens, 3 ones, plus 3 tens and 9 ones plus, okay? So we have a line here, so 9 plus 1, 10, 11, 12, 2, carry up 1, 10, 7, 8, 82. So we give the children this place value chart and let them use the place value chart, okay? So this is addition based on place value. So although in the standard written method, they're also doing addition based on place value, but here they use the place value chart. Okay, so they won't go wrong. So they won't write more than one digit in each place value. Okay, so this is the first alternative written method for addition. Okay. Okay. Okay, this is the second method. This is the expanded notation form. Okay. So for example, this is the addition expanded notation form. Okay. For example, if you have 52 plus 31, how do we do this? 52 is also equals to 50 plus 2, and 31 is 30 plus 1. Then you add this way. Okay. You add down like this. 2 plus 1 is 3 plus 80, which gives us 83. Okay. This is an algorithm based on expanded notation. We separate the numbers out into the tens and ones, into their place values, and then we add. Okay. Okay. We can also have an addition expanded notation in word form. For example, 52 plus 31. Same example we're using. 52 plus 31. We can write this as 5 tenths and 2 ones. And here second number, we have 3 tenths and 1 ones. Okay. Then we add according to ones and tens. 2 plus 1 is 3 ones, and this is 8 tens. 8 tens and 3 ones. Okay, so this is 83. Okay, any questions so far?
No, madam.
Okay, so we go on to the third alternative algorithm.
Madam,
Yes.
if the answer is exceed 100, how to...
Just a second, please. You're talking about this, is it?
Yes.
Okay. So if it's exceed 100, I'll give you another example, okay? Maybe tens.
For the answer.
Yeah, I know what you're saying, okay? So it's, if supposing it is like 43 plus 39, okay? 43 plus 39, okay? So this will be 4 tens and 3 ones, and this will be 3 tens and 9 ones, okay? So when we add this will be 11 ones, and this is 7 tens, correct? 7 tens and 11 ones. So this is one, we do the exchanging, 1 ones, bring 1 here. So we have 8 tens and 1 ones. So it is 81. Okay, so after you add, you can still go to another step here to do the exchanging. Okay, same thing lah, hundreds or so. Okay.
Okay, understand, madam.
Okay. Okay, let's go to the next one, partial addition. Okay, partial addition. This is for either 2 numbers, 3 numbers, or any number of numbers, okay? So when we do partial addition, we have, like in this first example here, we have 3 numbers. So we start by adding the 1. So 5 plus 6 plus 6 is 17, right? So we only add the ones and we write the answer here, 17, okay? And then we add the tens. The tens is 25 is 2 tens. 7, this is 2 tens. 7 tens and 4 tens. So how many tens are those? 7, 8, 9, 10, 11, 13 tens. So 130, 13 tens, okay? And then we look at the hundreds. We have 100 plus 200 plus 100. Altogether we have 400s, okay? Now we add together, okay? So this is our answer, okay? This is actually quite easy to do, quite a good algorithm, because here when they add according to place value here, they only add single digits. All the while they add single digits. And then with this part here, you see there are a lot of zeros. So it's very easy for them to add. Okay, so this is partial addition. We have another example on the right hand side. 7 plus 4 plus 6 is 17. So this is 17, and then we plus the tens. 9, 3 and 4, 9, 10, 16. So 160, correct? And then we plus the hundreds, 5, 4 and 2. What do we get there? 5, 4 and 2 will be
110.
But 9, 10, 11, 12, 16. Okay. 110, okay. Okay, and then the last thousands, how many thousands do we have? 14 thousands, correct? 14 thousands, okay? So add all the numbers because there are a lot of zeros, it's easy to add, okay? 7, 6 and 1, 7, 2, 5, 1. Correct? Did I do correctly?
Yes, madam.
Okay. So you see, how do we get 17 is 7 plus 4 plus 6. How did we get 160? 90 plus 30 plus 40. 1,100 is 500 plus 400 plus 200. And the last number here is 3,000 plus 4,000 plus 7,000. Okay, so this is called partial addition. We add part by part according to the place value. Okay. Okay. The next method for addition is called the scratch method. Okay. In this method, we add from the left to the right. Okay. Normally we add from the right to the left, but this method we add from the left to the right. We scratch the used digits and record the total on top. Okay. For example, the Okay, for example, we look at the first example here. So we start from the left-hand side. So 2 plus 9 is 11. So 2 plus 9, we've added both already. Okay, so we scratch it out. 2 plus 9 is 11. We write on top here 11. Okay, and then 5 plus 6. So 5 plus 6 is
11.
11, right? So it is supposed to be right. We write here 11. So we write 1 here. We cancel this and write 2, correct? 1 and 1 is 2. Then 9 plus 5. 9 plus 5. We've added this, so we scratch it out. 9 and 5 is 14. 4 and 1 over here. So we scratch this and we write 2. That's our answer. 1, 2, 2, 4. Okay. Let's look at another example on the left, right here. Okay. So 4 plus 5 is 9. 4 plus 5 is 9. 9 plus 3, 12. So 1, 2. Okay. Then second row here, 9 plus 8 is 9, 10, 17. 17 plus 4, 21. 1, we're supposed to write 2 here. So instead of writing 2, we scratch this and we write 4. We add together with the other number there, okay? Then third row, third column is 3 plus 2, 5. As you add, you scratch. 3 plus 2, 5. 5 plus 6, 11. 1. Another one we're supposed to add here. So we scratch this and write 2. So the answer is 1, 4, 2, 1. Okay. This is called the scratch algorithm. Okay, so we finished that. Next is the lattice method. Okay. Okay, lattice method is we need to draw some lines here. Okay, and we draw lines like this. Okay. So 6 plus 5 is 11. So we write 1 here, 1 here. Okay. 8 plus 9, 17. 1, 7. Okay. 1 plus 2, 3. The ones at the bottom, the tens on the top. Okay. Then we draw our line and we add the numbers. When we add the numbers, we add according to the diagonal. So this is 1. The second diagonal here, we have 1 plus 7 is 8. Third diagonal here, 1 plus 3 is 4. So when we add this way. Okay, we add this way according to diagonal. So the answer is 481, like this method. So another example, 2396 plus 159. Okay, so we have okay, 6 plus 9, 15, 1, 5. 9 plus 5, 14, 1, 4. 3 plus 1, 4. You can put 0, 4 or just 4 at the bottom. And then 2, bring it down here. Now you're going to add according to the diagonal. 5, 5, 5, 2. So that's the answer. Okay. So the reason for this algorithm is so that students can add just by using basic facts of addition. Okay, just using basic facts for education, they can come up with the first row here, and then very easy for them to add because they are all basic facts and small digits, single digits. Okay, so this is lattice method. I think this is in the textbook already. Yeah. Oh, this is addition based on basic facts. Okay, how do we do this? Addition based on basic facts. So first, 3 plus 2, we start from the right, okay? So 3 plus 2 is 5, okay? So 5 is, we write here 5 ones, 0 tens, okay? And then 5 plus 6 is 11. 11 is 1, 1 and 1 tens, okay? So now this is the last answer for the ones. So this one, we put it down here. This one here, we carried up here on this side. Okay, so 1 plus 9 is 10. Okay, so we write 0 and 1. So we are adding digit by digit. So now the 0 ones, 0 plus 8 is 8. Okay, so that 1 is still here. This 1 is still here because that is hundreds. Then 8 plus 4 is 12. 2 and 1. This 2 is the last ones that we added. So bring the 2 down here. Okay. So here we have 1, 1 and 1, 1 here. You have 1, 1 here and 1, 1 here. So 1, 2, take up 2 here. Okay. 2 plus 4, 6. 6 and 0. 6 plus 5, 11. 1, 1. 1 plus 3, 4. Okay. 4. So 4, bring it down here. On this side, we have 1, which we take it up here. So it's 1, 4, 2, 1. Okay? Can understand this method?
Yes, but a little bit messy.
But this is actually good for weak students. You know why? Because they don't have to keep on adding many numbers together. Each time they only add one number. I'll give you another example, a simpler example, okay? Let's just try this, okay? 26 plus 14 plus say 15, okay? Let's do this. So how do we do this according to basic stacks? First, 6 plus 4. 6 plus 4 is 10. 0, 1. 0 plus 5, 5. We can write here also 5, 5. Then we go 110 here. This 110, write it on this, on the right hand side, okay? Now 1 plus 2, 3. It's 0, 3 if you want to write that. 3 plus 1, 4. 4 plus 1, 5. Okay, so they plus a single digit at a time. Each time they only need to know basic facts to do this. Okay, this algorithm is very good for students who are quite weak. Then it's easy for them to add little by little at a time. Okay, so this is called addition based on basic facts. Okay, so we have finished with how many did we do? How many alternative algorithm were there?
7.
7, huh? So we had addition based on place value. We had addition expanded form. And then we had addition, partial addition. We had addition of scratch method, lattice method, basic text method, and also the expanded word form. Okay. Yeah, I forgot to tell you, you should go, as I'm doing, you should also copy it down and do it together, okay? Okay, now we're going on to subtraction. Subtraction alternative algorithms, okay? Okay, first one is expanded notation, just like how you did for addition, okay? Same thing, okay? 63 minus 27. So this is 60 plus 3. This is 20 plus 7, okay? Now you want to minus this whole thing, okay? So how do you do this? 3 cannot minus 7. So what we can do is rewrite 60 plus 3 to 50. We borrow 10 over, so 50 plus 13 minus 20 plus 7. 13 minus 7 is 6. 50 minus 20 is 30. So the answer is 36. Okay. Expanded notation. So we break down the number, decompose the number, and we do it. Okay. Same thing for word form. Okay. Place value chart also same. Okay. So I don't think I need to do this. Place value, just put into this chart here and minus. Okay. And then go on to okay, this is equal additions subtraction, or it's like a borrow and payback method. They call this the borrow and payback method also, okay? So let's look at one example, 63 minus 27, okay? Okay, so 63 minus 27, okay? So you know that 3 cannot minus 7. So we call it borrow and pay back. So we borrow from the 6, 1. So this becomes 10, okay? So we borrow 10 once, okay? From the top number, we borrow 10 once. And when we borrow 10 once from the top number, we pay back immediately to the bottom number here. From the 7, we give back 1 here, okay? So now we have 13 minus 7 is 6. And 6 minus 3 is 3, 36. Okay, if you another example, 432 minus 176. So 432 minus 176. 2 cannot minus 6. So you borrow 1. When you borrow 1, straight away you pay back here at the bottom number. Okay. So 12 minus 6 is 6. Now you want to minus 3 minus 8, but cannot. Borrow 1, pay back here. 13 minus 8 is 5, and then here we have 4 minus 2 is 2. So the answer is 256. Okay, so when you borrow and pay back, you don't have to reduce the number like 4. You already borrow 1, you don't have to reduce because you already pay back at the bottom. Okay, can you understand this method? How's the method? You like this method?
Yeah,
You don't like this method?
Confused, sometimes confused.
Why?
it's okay.
Because if we for the above part we add once 110 mean it become 12, right?
Yes.
If we give 1 to under, just add 1, not 10. So
Yes, add 1 only. Yes, correct.
sometimes confused.
Yes, because you know why? We are so used to the standard written method. So when we look
I
at this, that thing is already interfering, okay? The other knowledge is already interfering. That's why it's difficult for us to do this. But if for children who are learning all at the same time, some of them might like this method. Lah. Okay? So it's
Madam,
up to the teacher and the students, okay? Which method they want to use.
Madam,
Yes?
can you back to
Go back there. Okay, wait.
uh,
Go right in.
Madam, for second example,
Okay.
can we say, boleh ke kalau kita tak cakap 4 minus 2, but just say 1, just 2, 1 plus 1.
1 plus 1. You mean this one up here, is it?
Yang kan contoh, sebab saya tengok macam contoh 1 dengan 2 tu, kalau just plus nombor bawah 2 plus 1 is 3, then contoh kedua 1 plus 1 is 2. Macam tak perlu for
Oh, like that.
minus.
But okay, that depends on your explanation, but you must make sure that it's works for all numbers, lah. Okay, like what we call this, what did I tell you? Equal addition or pinjam dan bayar balik. Okay, so when you pinjam one here, terus bayar balik. Okay, pinjam satu terus bayar balik. So students will remember that very easy. So that means that they don't have to cut, or like they don't have to do 4 minus 3, 1 is 2, 3. They don't have to do all this. No, they don't have to cut this and write this here 2 like that. Straight away they pinjam bayar balik like that. Okay. So actually, I think I would like to do this. It's very easy, especially I think for weak students, they can do this very well. You can use any explanation that you want, okay? As long as it works for all numbers, then it's okay, lah. So you must make sure that there's no example that it doesn't work, that don't work for, lah. Okay? Okay, let's see. Okay, so the next one is complementary method, or shopkeeper's method. Okay. Example, 700 minus 123. Okay, so why do they call this shopkeeper's method? Is say you go to the shop and you buy something for 123 ringgit, and you give the shopkeeper 700, say, for example. How does the shopkeeper return the money to you? He doesn't, you know, in those days, or they don't use the calculator and all that, but they return the money layer by layer, you see, level by level. So this is the shopkeeper's method. So in this method, you start with 1, 2, 3. Okay, you start with 1, 2, 3, and 1, 2. We try to make this a whole round number. If we want to make this to the nearest 10, we add until 130. Correct? 123. Take to the nearest, round up to the nearest 10, so 170. So how much have we added here? We have added 7. Correct? Okay, from 130, we round up to the nearest 100, which is 200. How much have we added? We have added 70. All right? We have added 70. We want 700. So from 200, we go up to 700. Easily we can go up. We have added 500. So the answer is 577. Okay? 700 minus 123 is 577. This method normally we use for when you have a multiple of 10 number, okay, which is easy for you to minus. Say you have 900. 900 minus 324. So how do we do this? We start off with 324. So now you must make this into 330.
30.
Right? So how much have you added?
6.
6. From 330, we make this into?
Nearest 100.
How much is that? 400. How much have we added?
70.
70. From 400, we go straight to 900, which is?
At 500.
Yes, we have added 500. So the answer is 576.
It's like addition.
Yes, this is how the shopkeeper pays you back the money. When you buy something for 324 ringgit and you give the shopkeeper 900, so this is how he takes out the money and give you. First he gives you 6 ringgit, then 70, and then another 500. Okay, because he's actually doing this mentally. Okay, from here he's going to here and then he goes here and he does this mentally. So that is how he's paying you the money. So when you calculate that your balance, that is the balance lah, total. So this is called complementary method or shopkeeper's method. Okay. Okay, that is all I have for subtraction. Okay, so now we're going on to multiplication. Okay, multiplication, partial multiplication. Okay. Okay, 1 minute. Okay, do a simple example first. So 27 times 5. Okay, so for addition we did we added the ones, then we added the tens, and then we added the hundreds. Okay, similarly for multiplication we multiply the 7 and 5 first. 7 times 5 is 35. Then next level we multiply the tens. Here is 20. Okay, we have 20 tens here. 20 times 5 is 100. So the answer is 135. Okay, so this is actually 7 times 5 and this is 20 times 5. Okay, or another example, 27 times 42. Okay, first we add 7 and 2. 7 times 2 is 14. This is 7 times 2. Then we add 20 times 2. Okay, 20 times 2 is 40. After that, we add 7 times 40. 7 times 40, which is 280. And then last will be 20 times 40. 20 times 40 is 2 times 4 is 800. Okay, so this is 4, 12, 13, 3, 10, 11. 1134. Okay, this is called partial multiplication. Okay, this actually follows the area model, which you will see later. Okay, can do this.
Yes. It's more like standard written method. Like,
Yes, but standard written method usually we don't show all the steps.
yes.
Okay, now we look at area model. Okay, this is very visual kind of thing. Okay, so let's look at example 27 times 42. So as I told you before, this one, whenever you look at multiplication of two numbers, you must always think of a rectangle, the area of the rectangle. These are dimensions of the rectangle, panjang and lebar. Okay, so you have 27. Okay, so this is our rectangle here. Say, let's just say the one side is, it can be any side. Okay, one side is 27, so this is 20 and this is 7. Okay, and the other side is 42, so we put here is 40 and 2. So this part here will be 40 times 20. This is 40 times 7. This is 2 times 20 and this is 2 times 7. Correct? So if we were to write this out as partial multiplication, we would write this as 14, 40, 280, 800. The same example that we did just now, isn't it? Okay. So this is the same thing. This 40 times 20 is 800. 2 times 20 is 400. 40 times 7 is 280. 2 times 7 is 14. So this is where our partial multiplication come in, okay? So this first row is 2 times 7, the ones, 2 times 7, and then is 40. 40, yeah? Then we have 40, this is 2 times 40, and then we have 7 times 40, okay? 7 times 40, and then 20 times 40. Okay, so then this is your answer.
So we just add all the amount in the box, right?
Correct. So so if you're just using area model only, we just draw the box like this, add all the answers. Okay, but this is just to show you that this actually relates with the partial algorithm. Okay, so if you had an example like this, if you had just 14 times 12, okay, 14 times 12, so the child can just draw an rectangle. So this is 10, 4, 10, 2. This will be 10 times 10, 100, 10 times 4, 40, 10 times 2, 20, 4 times 2, 8. So the answer is 100, or you can start with it like this. 8 plus 20 plus 40 plus 100, which is 8168. That's the answer. Okay, some children like to draw. So when they like to draw, if they are visual learners, they like to find the answer like this. They can use this method. Okay, so this is called the area model method.
And then why the size of the box is not the same?
Because it's tens and ones. So the tens we draw it a little bit bigger.
Oh, okay, understand.
Okay, then. Okay, array model is very similar to area model. Array model. Okay. It's very similar to area model. Okay, supposing I had an example here, 48 times 58. Okay, and I want to find this. Sorry, it's let's give me a bigger number, 248 times 58. So this is multiplication, okay? So I put here multiplication, 248, I break up this number, okay? 240 and 8. This number, break it up to 50 and 8. So this is 200 times 40 times 8. On this side is 50 and 8. Same thing like the other one, okay? So here we just not drawing out, we're just straight away multiplying. 200 times 50, 2 times 5 is 10, add the 3 zeros. 40 times 50, 4 times 5, 20, add 2 zeros. 50 times 8, 40, 0. 200 times 8 is 10, another 2 zeros. 40 times 8, 4 times 8 is 32 and 0, 8 times 8 is 16. Okay, then you just add up everything and get your answer. Okay, which is, I think it's 14384. Okay, this also correlates with the partial method. Okay, if the partial method you do, you'll actually get all these values. Okay, you'll get 6 rows and then you add it all up. So this is the array model, same as the area model, just here we don't draw the rectangle, that's all. Okay. Okay, then we go on to lattice method. This is a very popular method nowadays. It's already in the textbook already. Lattice method. Okay, example. 27 times 42. Okay, so for this you have to draw, you have 2-digit numbers, so you have to draw like this. Okay, 27 times 42. So you will write 2 here, 7 here. Anybody knows this method? You already know this?
No.
Yes, madam. We call that
Yes.
box.
box. Okay, it's actually called like this method. It is in the textbook and you have to teach it in schools nowadays, okay? And it's also a very good method. 27 times 42, and then you draw lines like this along the diagonal. Okay, just like how we did for addition, okay? So now we start multiplying. 7 times 4 is 28. So the 1 is always at the bottom, the 10 is on top. 7 times 2, 14, 4, 1. 2 times 4, 8, 8, 0. 2 times 2, 4, so 4 and 0. When you add along the diagonal, okay? So this is 4, 8 plus 1, 9, 9 plus 4, 13, correct? 3, 1, 8, 9, 10, 11, 1, 1, 1 here. So this is 1, okay? So when you read from this way, the answer. Okay, so the answer is 1, 1, 3, 4. Okay, easy. Actually, it's quite easy. Okay, it breaks down the multiplication into basic facts. Say you have another number 1, 2, 4 times 3, 2, 4. Okay, you have two numbers like this. So how many boxes must you draw now?
9.
Yeah, 9 boxes. Okay, so 1, 2, 4 and 3, 2, 4. Okay, then draw your diagonals. Okay, so 4 times 3 is 12, 2, 1. 4 times 2, 8. 0, 8. 4 times 4, 16, 6, 1. Second column, 2 times 3, 6. 2 times 2, 4. 2 times 4, 8. Then 1 times 3 is 3. 1 times 2 is 2. 1 times 4 is 4. I just didn't draw it very well. Okay, so now you add. So it's 6. 8 plus 8, 16 plus 1, 17. 7, 1. So 4 and 4, 8, 9, 10, 11. 1, 1. 6, 7, 8, 9, 10, 10. 0, 1. This is 4 and this is 0. So your answer is 40176. Correct? Okay, actually students can do this very fast. Okay, it's faster than the standard written method if once they catch on. Of course, when we teach, we always start with small numbers first until they master everything. Then challenge them for bigger numbers. Okay, so this is lattice method of multiplication. And then we go on to this one. These are all alternative algorithms. The reason I'm teaching you all this is because all this came out in the exam before. Before we had a face-to-face exam, isn't it? We had like 3 hours and you have to, all this comes out in the exam. So because of that, we have to teach everything. It's just now you're lucky because it's OBT, it may not come out also, we don't know, okay? So example, 1, 4, 26 times 34, okay? So how do we do this method? First, we draw a line in the center here. And then we put one number on this side, 26 and 34 on this side, left-hand side and right-hand side, okay? On the left-hand side, we divide by 2 until we reach 1, ignoring all the remainder. On the right-hand side, we double it times by 2, okay? So we start with the left-hand side, okay? So 26 divided by 2 is 13, no remainder, okay? 13 divided by 2, 6, remainder 1, forget the remainder, okay? The 6 divided by 2, 3. 3 divided by 2, 1, remainder 1. So we've reached 1 already, okay? Then when we reached 1, we can stop here. Then we do the left-hand side. 34 times 2, 68. 68 times 2,
136.
Yes, 136 times 2.
272.
Yes, do it mentally, okay? 272. 272 times 2.
454. Is it?
544. 544. Okay, good. Okay, so now when we finish, so when we come to same level as the one, we stop already. Okay, now cancel out all the rows with even numbers on the left hand side. Okay, so you cancel all this already. Okay, cancel that. So what is left? We add 68, 272, and 544 on the right hand side. We add this, we will get 14, 1, 8, 8, 884. That's the answer. This is the Egyptian multiplication method. Can I understand? So later, after this, you have to go and try out with other examples, okay, until you understand. Anybody don't understand this? We write the numbers in 2 columns. Left-hand side, divide by 2 until you reach 1. Right-hand side, times by 2. And then cancel out the even numbers. Okay, cancel out the even numbers and you add remaining numbers. Okay, and you get your answer. Okay with this?
Madam,
Yes?
cancel the even number for only left hand side.
Yes. You start from that. You look at the left hand side and cancel the whole row.
Okay. And the answer count only on right hand side.
Yes, correct.
Oh, for the answer.
Okay, let's do one more example. A little bit harder, okay? I don't know if this is a good algorithm or not, okay? So let's try this 1, 4, 6, and 37. Okay, so what do we do? 146 divide by,
2.
how much is that? 73, right? 14 divided by 2, 7, 6 divided by 2 is 3, 73. 73 divided by 2 is
37.
36, remainder 1, 36 divided by 2, 18, 18 divided by 2, 9, 9 divided by 2 is 4, remainder 1, don't care about the remainder, 4 divided by 2 is 2, 2 divided by 2 is 1, okay? When you reach 1, stop. And then right hand side times 2, 37 times 2, 74, 74 times 2, 148, 148 times 2 is 296, 296 times 2 is 400, 592. Okay, 592 times 2 is 1,000, 1,184. 1,184 times 2, 1,000, 2,000, 2,368. 2,368 is 4,600, 736. Okay, so we got the numbers. Now cancel out all the even numbers. Cancel the whole row. Okay, all the. So what is left is only these numbers. Okay, so these 3 numbers, if you add it up, you will get 2 and 1,
5402.
5402. Okay, so this is the answer. Egyptian method. Okay, this is how you do it. Okay, so now we're going to look at okay, we're going to look at this first. Intersecting lines method. Okay, so how do we do that? Intersecting lines. I think, I don't know whether you have seen this method before. Anybody have seen this method before?
Japanese method, madam.
The one that we draw lines.
Yes.
Okay. Okay, let's try one example. Say 37 times 43. So what do? I want to use a ruler. Okay. Okay, so 37. So I need to draw 3 lines or, okay, I'm going to do 43 first, okay? So 1 line here, 1 line, 2 lines, 3 lines, 4 lines, okay? And then on this side, I have 4 and 3, yeah? 43, 4 and 3, okay? So in this side, I'm going to draw 2 lines, 3 lines. 1, 2, 3, okay? And then I'm going to represent the other number, okay? So the other number is 37. So I'm going to draw 3 lines and 7 lines, okay? So 1, 2, 3 lines, and then is this the Japanese method? 1, 2, 3, 4. Okay, I'm going to change this question. 34 times 43, okay? 34 times 43, okay? So I have 34 is this 1, 2, 3, 30 and 4. 1, 2, 3, 4, 34, okay? This way I have 1, 2, 3, 4 is 40, 1, 2, 3, 43. So I have represented both the numbers, okay? Then I'm going to count the number of intersections in this area. How many intersections can you see in this area?
12.
12, okay. How about this side? How many intersections there? 1, 2,
12.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How about in the middle, on top and in the bottom? On top here, how many? Here 9, right? At the bottom here?
Uh, 16.
16 here. Okay, so now we can write our answer. How do we write? We start from the bottom here, 12. So we have 12. In between here, we have 16 and we have 9. So 16 plus 9 is 25,
25.
correct? So 25, so 5, 2. On top, we have 12, which means 2 and 1. So we add this together, we get 2, 6, 4, 1. Can somebody check with their calculator if the answer is right or not? 34
Yes.
times 43, correct? Yeah? So 1,462. Okay, this is the intersecting lines method. Okay, let's try something easy. 12 times 22. 22, okay? Okay, 12. So I want to represent 12. So 1 and 2. 1 line and 2 lines, okay? So 1 line here, 1, 2 lines here, okay? And then 20, say 23, like 23, yeah? So 23, if I represent the first number vertically, the second number is horizontally, 23, okay? So 1, 2 up here, 3 down here. So both the numbers are represented already. So draw like this, count the number of intersections, 1, 2, 3, 4, 5, 6 here, here, 2. Over here, 1, 2, 3, 4. Over here, 1, 2, 3. So these two numbers we will add together. These two numbers we will add. So we have the ones from here. So we have 6. Okay, so we have 6. And then second number is 7. Third number is 2. So it is 276. Alright?
Yes.
Okay. Is that okay? Everybody understand?
Yes.
This is a good method also, okay? You can do calculations, I mean like three-digit numbers times another 3-digit number. You can actually do it very fast, okay? I actually like this method. It's a nice method. And then we have partition algorithm, partition method. Partition method is like this, example. 26 times 34. We partition one number first, okay? Say we partition 26 first. 26, we can partition it to 10, 10, 2, 2, 2, correct? We can break this down so that it's easier to multiply. 34, we don't partition. So 10 times 34, 10 times 34, 2 times 34, 2 times 34, 2 times 34. This is, straight away we know that is 340, 340, 34 times 2 is 68. Also can be done mentally, all these things, okay? And we add this up, so we will get 884, okay? Or you can partition the second number, 36 times, 26 times 34, okay? So we break 34, 10, 10, 10, and 10, 10, 10, sorry, 2, 2, 2, because it's easy to multiply by 2, just double it, okay? So times by 26, we keep 26. So we get 260, 260, 260, 26 times 4 is, times 2 is 52, 52. Add this up, you get 884. It's the same, whichever number you can keep any number and partition any number, okay? So this is also quite a good algorithm because you're just breaking down the number and so that you can multiply mentally. All this whole thing can be done mentally, okay? So this is called the partition method. Okay, this is the Vedic method. This Vedic method is from India. It is being taught extensively in schools, in Indian government schools, and also they also teach in UK and many other countries. We also have private institutions here teaching this method. Okay, this method consists of, I think, if I'm not mistaken, 16 principles, okay? So I don't know all the 16 principles. I only know one or two, which I've learned for this only, okay? So I'm going to show you just one or two examples only. The first example is, I think it's vertical and horizontal method. Okay. In Malay, we call it menegak dan merentasa. So example, 7 times 8, okay? So if I want to do 7 times 8, I would write it like this, 7 times 8. And then I would find the difference between 7 and 10. How many move to 10 from 7? Difference between 7 and 10 is, because these are single digit numbers, 1. So different, I'm using 10. So difference between 7 and 10 is 3. Difference between 8 and 10 is 2. So I write this down here, okay? Now, minus 3, you can do 8 minus 3 or 7 minus 2. What is 8 minus 3 or 7 minus 2? 8 minus 3 or 7 minus 2. So that is 5. Write down here 5, okay? So next step will be, we already have 5 here. Next step is times these two numbers. 3 times 2 is 6. So the answer is 56. Okay, so if I had another example, 6 times 7, I would write 6, 7. Difference between here, I would write, difference between 6 and 10 is 4. Difference between 7 and 10 is
3.
So either 7 minus 4 or 6 minus 3. The answer is still the same. It is 3. 3 times 4 times 3?
12.
12. So when it's 12, it is 2, carry 1 here. So it is 42. Okay. You can try this for other examples. I just want to try for one more example. Say 96 times 92. How do we do this? So I write here 96, 92. What do I write here?
200.
Okay, just now
Four.
you saw difference, because this single digit, we found the difference to 10 here. double digit. So we're going to find the difference to,
100.
yeah, so what do we write here?
4.
Yes, down here.
8.
Okay, so what's the digit here? Same method, 92 minus 4 or
88.
yes, 88, yeah? And over here,
36.
32, huh?
32, sorry.
So the answer is 8832. Okay, so let's do one more. 105 times 111. So we write here 105, 111. What do I write here? Okay, wait, before that, before that, I want to do this first. 11 times 12. So I write here 11 and I write 12. So what do I write on my right hand side?
9
9.
or 1.
Yes, it's 1, but it's more than 10, right? So it's negative 1. Okay,
Oh.
so here is negative 2. Okay, so here will be, what's that? What value do I write here?
9.
How do we get the answer? We minus, right?
Or 13.
Yes, it's 13. And over on this side, the right hand side will be
2.
2, yes. So it is 132. We already know the answer. 11 times 12 is 132. Same method we're going to use for 3 digits. 105, 111. So on this side, I'm going to write
Negative 5.
negative 5 and
Negative 11.
negative 11. Okay, so down here will be
116.
116. And over this side is
33.
55.
55. 55.
Okay, so the answer is 11655. Very fast, huh? So if you learn all this very fast, you can do, okay? So you can experiment with bigger numbers later when you look through this, okay? Actually, it's quite challenging to work it out for bigger numbers, okay? Okay, this is a Vedic method. This is horizontal and vertical. There's another one, another principle that's called crisscross method, also Vedic method, crisscross. They have a lot of principles, okay? So crisscross, darab silang, crisscross is darab silang. So say we have 32 times 44, okay? So here we're going to do it this way, 32. So 32, 32, 44. So now we multiply, okay? So 2 times 4 is 8. Now we cross multiply here and add. So 4 times 2,
8.
4 times 2 plus 3 times 4 is how much? 4
20.
times 20, correct? 20. So we write in the center here. 20, 0, we want to carry 2. So 2 we put in the bottom. And then 3 times 4 is 12. 12 plus this 2 is 12, 13, 14. So the answer is 1408. Something you check with the calculator, okay? Okay, let's just try one more example. 62 times 46. 6, 2, 4, 6. 2 times 6, 12. 2, carry 1, okay? Now times this 2 and plus. 4 times 2, 8. 8 plus 36.
42.
42 and this 1 here.
43.
43. 43. Are you sure it's 42, 43?
Wait.
6 plus 8.
44, 45.
45, okay, 45. So 45, 44 plus 1 is 45. So 5, carry 4. 6 times 4, 24. 24 plus 4, 28. 28. So the answer is 2852. Can or not? Everybody understand?
Madam,
Yeah?
it will. Can you start? Can you repeat again?
Okay, can. No problem. Okay, I'm going to do for one more example here. Example 96 times 92. Okay, so 9, 6, and 9, 2. First step is to multiply these two first. Okay, so 6 times 2 is 12. Okay, so we don't write like this 12. Okay, because it will be wrong. We must carry the number. So we write 2, carry 1. The 1, carry 1, we write at the bottom because we're going to use it later. Okay, second step is to multiply these two and add it together, plus how much do you get? 9 times 6, 54. 9 times 2, 18. So what is 54 plus 18 is 50, 60, 72, correct? 72. 72 and add with this one here, 73. So we write 3 here, right in the center, and then carry 7. Now these two we times. 9 times 9, 81. 81 plus this 7, 88. So it is 8832. Correct?
Okay, madam.
Okay.
Understand.
So if you understand, then using this method, okay, you work this out. You just see if you can get, if you can work out how to do this, huh? Okay, I'm giving you 3 digits now. Just now was 2 digits. How will you do it for 3 digits? You try first, huh? Give you a few minutes. Anyone know how to do this? You can guess how to do this? Okay, let's try this, huh?
I tried, but I got the wrong answer.
Okay, actually, because when I learned this from the internet, because it was free, yeah. When it's free, you only have limited access, so this part couldn't access. So I had to work it out from the answer. I think it's like this, okay? So we times this, 1 times 2 is 2, like how we did earlier, 1 times 2. Second one, so the first step is 1 times 2. Second step is 1 times 6 plus 2 times 4. How much is that?
14.
14, right? So it's 4 and 1, okay? So we did these two. Third step is 1 times 5 plus 3 times 2 plus 4 times, it's just, yes, plus 4 times 6, okay? 1 times 5 plus 3 times 2 plus this. So how much is that? 5 plus 6 plus 24. 35, correct? 35 plus 1 is 36. So 6 and 3. And then third step is 3 times 6 plus 4 times 5, which is 20, 30, 20, 38, 38, 39, 40, 41, 1, 4. Last step is 3 times 5, 15. 15 and 4 is 19. So the answer is 191642. Okay. If you see the pattern already, then it's very easy. Then you can work it out for 4 digits and 5 digits and so on. Okay. So basically it's on your right hand side, you times first vertically, you times these two vertically, and then you times cross multiplication, crisscross multiplication, add it, and then left hand side you times vertically, that's all. So if you have 3 digits, you have to do the crisscross 3 times. Okay? Okay, you can go back and work that out later. Huh? So this is the Vedic method. Okay, so we finished with multiplication. Now we're going on to division. Huh? So division, we've already looked at the standard written method. Okay, so this is the other way of doing division. Short division. This short division, bahagi pendek, also known as bahagi pendek. Say you have example 237 divided by 4. So you, sorry, then 950 divided by 4. Okay, so we write here long division will be like this. Okay, we do like this long division, but for short division we will do it the other way. Okay, 950, although we write it the same way, we won't be doing long. Okay, so 9 divided by 4, how many times does 4 go into 9? 2. So instead of long division, we will write like this, but we're not going to write like this. We're going to keep it in the mind, okay? 2 times 4 is 8, remainder 1. So we write the 1 up here. Now we have 15. 15 divided by 4 is 3. So we have 3 times 4 is 12. 15 minus 12 is 3. So we write here 3. Now it's 30. How many times does 4 go into 30? 7 times 28. So we got still 2 remainder 2. This is short division. This division method is for good students. A lot of good students, they don't like to do long division. They find it very tedious to write everything. They just prefer to do it mentally. So they do it like this. Okay, this is short division, also accepted. Okay, so this is the first algorithm, alternative algorithm for division. Okay, and then we look at okay, this algorithm is the fishbone method. I think there may be other names for it. So for example, 5, 6, 7, 9 divided by 23. Okay, this is how school teachers teach this. Okay, because it's divided by if it's a single digit number, it's quite easy. The students can do it quite fast. But because it's the double digit number, so there is no timetables for the double digit. So create your own one. So how do you create? It's like this. So we write the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, digits 1, 2, 9. So our number is 23. So we break it down to 20 and 3. Okay, so we write the 20s timetable first because it's a multiple number, so it's easy to write. So 20 times 1, 20. 20 times 2, 40, 60, 80, 100, 120, 140, 160, 180. Stop here. And then we write the 3 times table. 3, 6, 9, 12, 15, 18, 21, 24, 27. So this is 20, but we want 23. Okay. So for 23, this will be 20 plus 3, 23, 40 plus 6, 46, 60 plus 9, 69, 80 plus 12, 92, 115, 138, 161, 184, 109, 207. 207. Okay, so students have to build this. This is the fishbone. Okay, and I think they can build it quite fast if they are good in their multiplication. Then they can do it quite fast because this is multiples of 10. This is single digit, and this one they just add it together. Okay, so now they divide 56. How many 23s can go into 56? So look at the first one is 23, second one is 46, third one is 69. More already. So always take the last one. So this is 2 times. Okay, so this is 2. So it's 46 minus 10, 707. Search for 107. This is already 115. So we take the earlier one, 92. 92 is 5 times. 1, 2, 3, 4. 4 times 92. So it's 4 times here. So it's 92, 5, 1. 15, bring 9 down here. 159 will be 7, 6 times. 6. So 6 will be 138. So this is 6 here. minus this will be 1, 2. Okay, so the answer is 2, 4, 6, remainder 21. Okay, so this is called the fishbone method. It's all, I think this is also in the books. I see many teachers teaching this way also, lah. And it's actually a very good method to use to teach for double digits. So this is an alternative to the division algorithm. It is the same like the long division, it's just that you have this extra table there in the side. Okay. Okay, the next division algorithm that we want to see is this one, repeated subtraction. Okay, repeated subtraction method. For example, we have 648 divided by 24. So the repeated subtraction is 648 minus 24 minus 24 minus 24 until you finish everything. Okay, so instead of minus 24, we minus 10 times of 24. We minus one shot 24 many times. So to make it easy for us to minus, so we take 10 times 24, which is 240. Okay, so 648 minus 240 is 408. So we minus again another 10 of 24, that is another 240 we minus. Okay, so we get a balance of 168. So now we cannot minus 10, and if we don't want to minus the 3, 4 because the multiplication is difficult, but doubles is quite easily done. Okay, 24 times 2, we know straight away that it is 48. So we minus 48. So we know this is 120, sorry, 120, yeah. 120, then we minus another 48. So we have 72 minus another 48 is 24 minus 24. Now we minus 24 and we have 0. Okay. Okay, so here we have minus 10, we minus 10, here we minus 2, minus 2, minus 2, minus 1. So the answer is 10 plus 10 plus 2 plus 2 plus 2 plus 1, which is 26, 27. Okay, so 648 divided by 24 is 27. Okay, another example. Repeated addition, 789 divided by 23. Okay, so you start with 789, you want to minus 230, so you have minus 10 times 23. Okay, so what is your balance here? Now it's 559 minus another 230, that means you minus another 10 of 23, so you have 329. You can minus still another 10. Okay, so we have left here 99. 99, then we start minusing 2, 2. 23 times 2 is 46. Minus 42 times 23, 46. You have 53 minus another 46. We have 7. Okay, we minus another 2. So our answer is 10 plus 10 plus 10, 30, 32, 34. 34, remainder 7 is the answer. Okay, this is called repeated subtraction method. Okay, and the last one is the partial division method. Partial division method, say we have 789 divided by 3. So we look at the hundreds first. We have 700s. How many 3s can go into 700s? So we have 200s. 200 times 3 is 600. So we have a balance of 189. Now how many 3s are in 189? We have 63. So 180 minus this, we have 9. So this is 3. 3 times 3 is 9. We have 0. So answer is 263.